very much for the introduction. I must say that it's difficult to have a presentation now after the experience we had outside, the excitement about the Boras project, but I'll try to do my best. So thank you for the introduction, and thank you very much, Florence and Eric, for the invitation to give a presentation about this topic. And I would like to thank also Marin and Fingerhut for the very productive conversation and brainstorming that we had about this topic in the last probably 6-8 months. So my name is Emanuelle Cauda. I'm a senior fellow at the Pittsburgh Mining Research Division in NIOSH in Pittsburgh, Pennsylvania. I thought as a first thing it was a good idea to give you just a few words about NIOSH in the US. NIOSH is a National Institute for Occupational Safety and Health. So we are part of the Center for Disease and Control and Prevention, which is a larger federal agency within the federal government. And we are part of the Department of Health and Human Services in the federal government. Within NIOSH, the mining program is a well-established program. Our mission is to eliminate mining fatalities, injuries, and illnesses through relevant research and impactful solutions. And our slogan is Safe Mines and Healthy Workers. Our activities of the mining program are conducted in 2 different locations in the US, Pittsburgh in Pennsylvania in the east, and Spokane in the Washington state in the west. I work in Pittsburgh, and the activities are organized in different branches. My branch, I decided to put it up first because it's my branch, is the Dust, Ventilation, and Toxic Substances branch, but we work also in electrical and mechanical system safety, fire and explosion, ground control, human factor activities, and workplace health. In addition, we have a branch about health communication, surveillance, and support, which is a branch that is in common with our colleagues in Spokane, where they are organizing teams. They have 2 teams about ground control. They have a team about automation and technology in general, and a team about health exposure assessment and monitoring. So let's dig into the topic of this keynote that is about tools available for everybody from NIOSH. So NIOSH has been always very active in creating tools for occupational health and safety professionals. You can think about the Manual for Analytical Method or the Pocket Guide to Chemical Hazards that now is available for mobile devices as well, or dust control, handbooks for mining, for example, about dust control, ground control ergonomics, exposure to diesel emissions. So we've been very active for tools, but more recently there was a wave to create a new generation of tools available. And I think this statement from the director of NIOSH, Dr. Howard, that we got in the internal newsletter last week about the launch of the new NIOSH lifting equation app sum up really well this new generation, because this app adding to our growing suite of tools that brings our science and recommendation into the hands of workers and employers. And what do we have in our hands every day? And in front of us, I can see a lot of people on the desk. We have smartphones, we have tablets, we have laptops, we have devices that we use for our work, and more we can, and we are using them also for occupational safety and health activities in the workplace, in mining as well. So why we need tools? We need tools to assess, we need tools to do analysis, we need tools to do communication, to share the information that we get and we generate to the workforce, to the employers, to other partners for different projects. So my talk is gonna focus on different tools. I decided to call them tools and not apps, because most of them are actually apps for smartphones or for tablet, but some of them are actually softwares that can be downloaded and installed on laptops, and some of them are web tools. In the strict definition of terms, that means you are tools that can be used on the web, on the NIOSH website. Few of the tools that I'm going to talk about, they have the yellow triangle because they are still in the pipeline. They are in work in progress, but I thought it was a good idea to present them just to give you an indication of what is coming in the next months from NIOSH in terms of tools that could be available for everybody. So the first tool is something that has been released almost a year ago, a little bit more than a year ago. That is the NIOSH Sound Level Meter app. This is an app for tablets, iPad, or iPhones. It's only for iOS devices. I have here the information about where you can find information about this app, a blog article in the NIOSH blog page about this app. There are 2 YouTube videos about the features of this app and as a promotion. Has received really a lot of positive feedbacks. And let me give you a little bit of background. So they are on the market, means they are available, even though you need to pay them. There are a lot of apps already for noise, both for iOS and Androids. So NIOSH a few years ago tested 192 apps for iOS and Androids, and they found out that most of these applications are targeted for casual users. They're not targeted for occupational health and safety professionals. They have a limited functionality, they have a lack of metrics that can be important, and most of them, with few exceptions, they don't meet the criteria in terms of accuracy that we might need for occupational assessment for noise. So we decided as NIOSH to create our own sound level meter. Why we decided this? Because this way, this app is targeted for occupational health and safety professionals, industrial hygienists, occupational hygienists. The second reason is because in this way we can set up a standard, what could be the basic capability of a noise app for tablets or smartphones. In this way we can also raise awareness on noise issues and in the problem of noise in the work environment, and it can serve also as a research tool so the researchers can interact with NIOSH to improve and to make this app even better for the next generation. So this is just a display of the app. You can see all the functionalities. It can be calibrated in case of using an external microphone, and I have microphones for for who of you are going to be here on Friday morning to test this app. There have been extensive testing against more professional sound meter devices used by professionals in the field in workplace environments. This app is not intended to be used for compliance in the US or in other countries, but just as a tool to make exposure monitoring activities. The main features, I already mentioned a few of them. It's possible to have different sound level in different frequency. There's a possibility to have basic statistical analysis data at the end of one session of testing. There are some information about noise and hearing loss. The user can save different projects, can share the project results with other people. So all this is to provide a most comprehensive app as possible for this application. And finally, this is a slide that I put for every single tool that I'm going to talk about. I just decided to put the information about the most knowledgeable researchers in NIOSH about this specific tool. In this case, it's Chuck Cardus in NIOSH Cincinnati, and for mining application, Kansan at the Workplace Health branch. That doesn't mean that you cannot ask me a question at the end of the lecture, but I thought it was appropriate to say I'm not an expert on all of them, but there are people in NIOSH that you can contact to ask even more detailed questions that I'm not going to be able to answer. In the mining program, to stay in the field of hearing loss, I think this is an interesting web tool. So it's a tool that can be used online on the web page of the mining program, NIOSH web page, and it's a page about testing the hearing protection. And this page can be used for training, for example, for workers. They can go through periodic training for hearing protection equipment to test whether they are fitting the protection equipment well, or the fitting is not right, when it's right, when it's not. So it's a very clear and simple page, but I think can be very effective and useful for professionals in the field. Shifting gears from noise to dust and silica. In this case, the next tool is called Evade. And the background idea in this case is that we really wanted to work in terms of video and real-time sensor technology combined to provide a better monitoring approach for dust. So the idea of using video cameras and video footage to understand what a worker is doing during a shift is something that is not new. It's been done for several decades. What's new, at least in the US and around the world, is the availability of really small webcams. Webcams that can be at the helmet of a worker, can be at the shoulder of a worker. And so it's possible that a worker can carry that webcam through the shift, and the data can be used to assess the exposure through the shift to identify tasks when there's an high exposure. Related in this case, initially we decided to do it for dust, but I'm going to show you that it can be implemented for other issues. So just to give you again one more slide in terms of background, you can see here this is the real-time information about a dust monitor for a bagging operator. So you can see that this worker had a lot of times during the day where they had really high level of exposure for dust. And these peaks can be used to understand if there is a need for better engineering control technology, better workplace practices. But what is missing here? The context. We had no idea what this person is doing when there's this high exposure level. Traditionally, there's questionnaire, there's interaction with the worker. We need to ask them what he was doing. He needs to remember where he was at the specific time of the day. But in this case, it's difficult. The idea of the helmet cam is this information can be gathered by this webcam at the helmet. That's why we call it helmet cam. But it can be also put on a shoulder. But shoulder cam doesn't sound good enough. So we keep calling it helmet cam. And it's been designed especially for mobile workers. Workers that maybe they are not performing the same task all day. They are changing, moving around. So it's difficult to identify a problem of exposure. So to sync together the footage from a video and from a real-time dust monitor, we needed a software. We needed a tool, and this tool is called Evade. So this is the link where Evade software can be found and downloaded and installed to your laptop. This is a screenshot of Evade software, which stands for Enhanced Video Analysis of Dust Exposures. So you can see that you have the video on top, and you have your real-time dust monitor at the bottom. And you can really identify where there's an issue during the day. Just to give you an idea where to find it to help you a little bit more, this is the link for the NIOSH mining program website. There's a portion of that website is called Tools You Can Use. And there are some of the tools are highlighted on top, but there's a long list as well. So Evade software is here right now. And it's Evade 2.0 because we already are the second generation. And the second generation means that not only you can use a real-time dust monitor, but you can use DPM real-time monitor, a noise real-time monitor, organic compound, anything that can be a real-time can be used with Evade, with the video camera. Is it possible to use multiple channels, more than one camera, more than one sensor? It's possible to share the project with another person with the same software. And there are some basic data analysis that can be done, max, min, average, some very basic statistical analysis that can be done with the software. So this is just an idea of the software as is right now. You can add the real-time dust monitor on top, you can have the video on the bottom, and then you can do minimal analysis to identify the peaks. And just because I talked about the bagging operator, this is your bag, the real-time data that I hope you can see. So here you have your dust level that is very low, and this guy is driving a truck. And then the guy is getting a bag, and he's going to install the bag on a forklift, and he's doing this 100 times a day. And here's the more important moment. We realize that the problem is not the bag itself, it's when he opened the bag and he pushed the bag on the forks, that's when the dust level is high. So that was an understanding what to do, was not to clean the bags too much, but what to do when he was pushing the bag on the forklift. And that was the problem, and that's where we needed to find a solution. One more slide about this tool is the fact that this tool has been used already by a colleague of ours, Emilias, for health and safety risk communication tool. So the idea that these tools can be really used not only for the data they can generate, but also for what you can use with the data to improve the communication as an health and safety professional with workers, with managers, with health and safety corporate managers at different levels. And these are the content information for this tool. The next tool, which is work in progress, I want to stress about this, but I thought it fit well at this point of the presentation because it's about silica, is a new field-based silica monitoring approach that we are working on. We heard about for 2 days about the problem of silica and silicosis in any type of mining environment, both for formal mining or for informal mining. So one might think, okay, there are actually right now more and more real-time personal dust monitors, and some of them they can be used also in informal mining. They've been used already for environmental monitoring, and they can cost no less than like $100 to $200. And why not to use them for real-time silica? The fact is, the percent of silica in the dust, in the respirable dust, is extremely, extremely variable in a mining environment. So if you don't believe this about the silica content in dust, you cannot do real-time silica monitoring with a real-time dust monitor. And so we went, a few years back, we went to the blackboard and said, okay, where we can do better for silica monitoring. And the idea was, this is the circle that any industrial hygienist and occupational hygienist has in mind about silica monitoring. There's a collection of samples to handle the samples and send them to the lab. There's the analysis done at the lab. The data are back. In the US, the data are back generally after 2 weeks. In some parts of the world, I heard about up to 2 months the data are back. And then there's something that needs to be done, and there's an assessment of the control technology or intervention. So we think these 2 blocks can be improved if we can find a way to have the analysis of the samples at the mine site or at the workplace, immediately where you collect the samples. And so we've been working on something that is a field-based silica monitoring approach. And I hope I can show you 10 seconds of the video. So this is your respirable dust sampler, any type of sampler. And you can get a cassette with your dust sample, and you can put the cassette inside the instrument, and the analysis can be done in 2 minutes. So the comparison is 2 minutes with 2 weeks or 2 months. So you can imagine the benefit of getting the results back in a few minutes. So this is what we have, and it's almost reality. We are doing beta testing right now. This is a miner with a sampler. This is us in the field with the instrumentation. This is the dedicated cassette that we are using for this application, and the data can be back in less than a minute. It's actually a quite comprehensive initiative because we have different components that we need to work on. We are not actually creating a new instrument. The instruments for this application are already in the field, are already in the market. So anybody can buy this instrument, are infrared instruments. What we needed to do is to work on the application, and so to work on the equation, on the modeling, on all the math that was needed. And so we thought in this case also that we're gonna have, and we're already working and it's being tested in beta testing process, that we're gonna have a software that is gonna be freely available from the NIOSH website that is gonna help users that they don't know anything about analytical methods to do end-of-shift silica monitoring, to do field-based silica monitoring. So the software is gonna interact with the 4 instruments. They are commercially available that we are testing. It will incorporate all our knowledge in terms of modeling. And so why we need a software from NIOSH for this? And the idea is that NIOSH can in this way control and improve the quality of the monitoring approach and the analytical method, and we can interact with the people that are going to use it, the users, to revise and improving the tool, means the software. And the last reason, because it's going to be free. Otherwise, it's going to be a part of a package of an instrument, but it's our knowledge, so it's going to be free. And these are my content information because I'm personally involved in this project. Moving not to health, safety, the next tool is about ladder safety. This is a smartphone app. So out from the software perspective, this is app, so iPhone or Androids. This app is actually can be used on both of them. And these are the information about the web page where you can find the app and the YouTube video. This app, Ladder Safety, has two main features. There's one feature that is the angle measuring tool, which is a really interactive tool. And then there's Ladder Safety tools, which is pretty much about decision-making information, selection of the proper ladder, inspection of the ladder, setup, proper use. So the measuring tool, that is something that we're going to use and try and test on Friday as well, is really a tool that you can use your smartphone, and you can put the smartphone on the ladder, and the smartphone is going to tell you if the inclination, the angle of the ladder is safe, is on the safe level for the person based on the weight of the person and based on the type of the ladder. So it's really an interactive tool, but really simple and user-friendly. And these are the contact information for the researcher in the Division of Safety Research in NIOSH in Morgantown. Back to the safety as well. The next tool is called ErgoMine, and is a tool that has been designed in the mining program in Pittsburgh specifically. And so these are the information about the tool. So the tool is pretty much something that should help the health and safety professional to perform an analysis in terms of ergonomics. There are 3 different activities that have been selected, and so the idea is really for the professional to understand whether there is a problem from an ergonomic perspective and how to mitigate that issue. So the app is targeted for health and safety professionals, even though they don't have any ergonomic skills. It's designed exactly for people that doesn't have any skill at all. The app is organized in modules so that the professional can conduct the analysis on one module only or all of them. And the idea is really that it should not be used and done, should be periodically revised and periodically reused to understand if there's new issues in terms of ergonomics. And encourages really reliable and valid observation for ergonomics and provide recommendation when issues are identified. So these are the 3 tasks that have been included in the app, which is an app only for Android in this case. So it's for smartphone and tablets, Androids. The small and bulk bagging operation, all track, and maintenance and repair for processing plants. One thing that I was told to stress not enough is that it's not an audit for ergonomic programs, but it's a tool that can be used by occupational health and safety for activities outside the audit, the formal audit. And this is just how the app looks like in terms of one module. In this case is a module about maintenance and repair. And so there are really basic questions that anybody, even without any knowledge of ergonomics, questions that can be answered to go through the survey. And based on the answer, there are recommendations at the end of the module. And you can see that the questions are really supported by images and by some of them. I think there are even a couple of small short videos. So it's everything to help somebody that doesn't have any ergonomic knowledge to perform the investigation. And this is another example of a different module for bagging. So also in this case, there's a figure, there's an explanation, and then there's a question, and based on the answer, there are recommendations that are given. So also in this case, we have the contact information for the researcher. She's the one in charge of the ErgoMine. We are still in the safety environment. This new tool is actually a web tool. So it's not an app, it's not a software, but it's a tool that can be used online at the NIOSH website. And the concept is that safety pays in mining. They really wanted to investigate the idea of the cost of injuries and how those costs have an effect on the profit of a company, and how those costs, if the company is saving those costs because there are no injuries, that amount of money can be reinvested in prevention, in training, and in health and safety. So this, in my opinion, is a really interesting idea. The web tool is divided in different sections. In the first section, there are like common injuries. Let me go right here. So these are the common injuries for different commodities, coal mines, metal mines, sand and gravel. And the idea of this session is really to show that injuries can happen, and they do happen commodity by commodity, so that to give an idea that this is happening at which level. The second session is more interactive because it's possible to create and simulate different injuries. In this case, it's a sprain back, and there are costs based on a database for this injury. And these costs, they're not constant because there's a huge variability for the same injury. And so the researcher provides different statistical analysis on the several costs. And so the person using the app can select a more conservative level, which can be very high in terms of cost, or a less conservative, like, well, it's not going to be a big deal, this injury. Or it can set the company cost based on the location. And then there's information about the profit, the annual sale for the company, and the profit margin. And so the one injury that was added in the previous session, or multiple injuries, that they are calculating in terms of what is the percentage on the profit for that injury, and how much more sale you will need to do to get to the same level of profit. Now, I understand this is more for big companies, but the more I'm thinking about even in terms of informal mining, and I wonder, it's not that far from the idea of, okay, it's not a company, but it can be a country, it can be a state in terms of cost for compensation for workers. And so what is the cost of one injury or disease, and what's the compensation cost for the country? So the same analysis could be done at the same level. In the last session of the app, of the tool, is about understanding how much saving the money, because reducing the injury, can be reinvested into health and safety, or training, or any other type of prevention. So that's the whole idea for safety pays in mining. And I think it's fairly new and fairly still limited in terms of scope on just few injuries, but it can be definitely improved. And this is the contact information for the API guy working in Pittsburgh that is in charge of this tool. So the last two tools I'm going to go through are still work in progress, but I think they could be interesting. One is about an hazard recognition tool that is going to be a web page tool, so they can be accessed from the web page of the mining program at NIOSH. And the idea, this is for sand and gravel mine workers. They did a study in our virtual reality lab in Pittsburgh, which is a huge virtual reality lab, where they were inside the lab, and they had like a 360-degree projection of a mine, and they need to recognize different hazards. Because this was so successful, they thought, well, can we do the same thing for somebody that is not going to be in Pittsburgh? And so the whole idea is that create some panoramic videos, so the panoramic videos of environments, and this is just one type. And they challenge, that's why they call it hazard recognition challenge. They challenge the user of this web tool to identify the different hazards in that environment. And if the user doesn't recognize them all, or even if it was successful, he's going to get feedback, he's going to get additional information about that hazard, what to do with that specific hazard. And this tool will be available probably in the fall on our website. So I can show you what I did with the beta version for this environment. So there are some gas for welding, there's a vehicle, there's a forklift, there can be an hazard there. So you can really interact with the picture, and you can see the green bar at the bottom, so that's the time that is for the challenge. So you need to be fast. And then there's a chain, there's a saw there, and there are the bottles. So right now they are in beta testing, external beta testing. So I'm going to give you the contact information, because I know that they're really looking for beta tester, people that they might be interested to test this web application, to see if it can be done better, or there are things that can be changed. I'm not really sure how successful I was because they didn't tell me at the end. And this is the last app that I'm going to present. It's called Sleep, Trip, and Fall Hazard Assessment application. This is going to be for Android. And I have the beta version on an Android that we can use on Friday during the workshop. And the whole idea is that this app could be used in the future for observational work sampling. So for, again, safety. And the idea of work sampling is really to determine the proportion of time spent by workers with different hazards and in different categories of activities where there can be different hazards. And the gold standard are time motion studies with video-based observation, but it's very expensive, time-consuming, and so this is what is a video-assisted traditional time motion study. So there are different ways, like spreadsheet tables that can be used, and this app exactly is going to do this. It's going to be a very well-presented system where the different tasks can be listed. There can be information about the floor and surface and condition, where the worker was. There can be some ergonomic risk factors as well. There can be some specific hazard identified by pictures, by notes. And this is also from a time schedule perspective. So there would be a possibility to say for how long the worker was in this condition. And so at the end of the day, there can be an overall assessment of the full shift. And again, this is the contact information of the researcher involved in this application that is still in beta version. So this is the whole list of the apps, and I, while I was putting all together, trying to understand which one could be applicable not only for formal mining in the US, but formal mining outside the US or informal mining outside the US. Definitely, it was difficult to have a good perspective, and I'll be more than happy to hear feedback from anybody to understand what can be done. One thing that I would like to stress, though, is the idea that because all these tools are NIOSH tools, that means that we might not be in the position to change the tools for outside the US use, for maybe informal mining, who knows, in Indonesia and the Philippines, but that doesn't mean that somebody else cannot do it, because we can share the information about the tools with university or other groups that might be interested to work with us to try to make it better for a different environment. And that would mean also that it can be better in general, the tools, and it can be a win-win situation for everybody. One more thing that I wanted to stress is the fact that there's actually not a single place in terms of a web page where all these tools are listed. But while I was putting together, so I gave you all the web pages, the different web pages, but it's not a single one. They're all spread in the NIOSH website. So the more I was thinking about it, and I thought, well, actually the Center for Direct Reading and Sensor Technologies can be the best place because all these tools are actually direct reading approaches. You can use them in the field, you can use them at the work site. So I might try to talk with the directors, considering that I'm involved as a deputy director for this center, to try to see if we can list them all and have all the YouTube videos and all the information in a single place, in addition to their own pages. And with this, I hope I was in time with my presentation. I'll be more than happy to take any question. Here there are all my contact information. If you need to ask me any question, if I'm not in the field, I'm more than happy to reply and give you all the answer that I can give you. Thank you very much.